Okay, lesson 2 is on rational exponents. We're talking about real numbers that have exponents that are fractions. Rational means it's a fraction. Alright, so for any real number except if b is negative and n is even, you can write the square root or the nth root of b as b to the 1 over n power. So here we have x to the 1/2 power is the square root of x to the first power. And you see that 8 to the 1/3 power is equal to the cubed root of 8 to the first power. You think that there's a 1 there. All right, and then that simplifies to be 2, because 2 times 2 times 2 times 2 is 8. Okay, so basically the bottom number in the fraction gets planted and the top number stays inside. So if you have x to the 2/3 power, that would be the cubed root of x squared. And if you have y to the 4/5 power, that would be the 5th root, right? The bottom number gets planted, the denominator gets planted, that's the root, and then you have y to the 4th power on the inside. So the denominator goes, that's the root that you have, that's why it's a root of the flour, all right? And then you have your flour goes on the inside. Okay, so the bottom number is the root. So if we look at x to the 5/7 power, 7 is the root, so that goes there. And then you have x to the 5th. If you have y to the 3/6 power, well, that reduces to y to the 1/2 power. Okay, and then 2 is the root, or that would be the index. Remember that number is called the index. And then you have y on the inside, because that would be like y to the 1. So if I have 64 to the 1/2 power, all right, the 2 is the root, or the index, and then I have 64 on the inside, and then that's to the first power, so that's just 64. And then the square root of 64 is 8. So now I have 4 to the 3/2 power. So again, 2 is the root, so that stays on the outside. And then I have 4 is the radicand, right? That's my number, and that's to the 3rd power. And so if I do that on my calculator, all right, take the square root of 4 cubed. So I'm going to take the square root of 4 to the 3rd power, and that equals 8. Okay, because if I take 4 to the 3rd power, that's 64, right? So this was really the same as this one. This is square root of 64. And then we could also write 64 as 4 cubed. So it comes out to be the same thing. If I have a negative fraction, all right, if you have a negative fraction, a negative exponent, all right, that means that the fraction is in the denominator, and so you're going to have to rationalize the denominator. Remember, a negative exponent does not make the number negative, it is the reciprocal. Okay? Negative exponent equals the reciprocal. Okay, so it gets flipped over. So if I have b to the 1 negative 1 over n, that means that's the reciprocal. That means that goes into the denominator. All right, and that would be 1 over n means I have the nth root of b to the 1, and that's why we have that there. Okay, and then the negative means it is going to be in the denominator. Okay, this negative makes it go to the denominator. So for example, if I have 16 to the negative 1/4, the negative means I'm going to make it a reciprocal. So, and then I'm going to convert the 1/4 to a radical, and so this would be the 4 is the denominator, so 4 is the root. So it's on the outside, and the 16 to the first power is on the inside. And then 1 is 1, and then the 4th root of 16 is 2. All right, and now as a review, we have to remember the exponent rules because the fractions are exponents. Even though the exponent looks different, it's still just an exponent. So the rules still apply. And that's good. We just use the same old rules we've been using since the first of the year. Okay, so for example, if you're multiplying, all right, if you're multiplying and you have the same base, you're going to add the exponents. So notice I have this base, both of them are C. All right, and so now I'm just going to add the exponents. 2/5 plus 1/5 is 3/5. And then you can convert that, if you have a rational exponent, you can convert that to a radical. Again, the 5 is the root, so it comes to the outside. And then you have c to the 3rd on the inside. Okay, so multiplying means you add the exponents. All right, we took 2/5 plus 1/5, and that gave us 3/5. Okay. Now if I'm dividing, I'm going to subtract. All right, if I'm dividing, I'm going to subtract the exponents. So I've got the same base, right? They're both x's. So my answer is going to be an x, and then to get the exponent, I'm just going to subtract because these are, because I'm dividing. This means I'm dividing. So I'm going to take 2/3 minus 1/3, and that is 1/3. Right, the denominator stays the same, and you subtract your numerator, so that's 1/3. And then I can write that as, remember this is the root is on the outside, and then you have this on the inside. Oops.